My name is Michael Boman. I'm a security researcher working as an IT security consultant. I'm also a father, 5 wonderful kids, 3 months up to 15 years old. And I have a hobby, a strange hobby. I like to collect malware. I like to analyze malware. And I was thinking about explaining how I combine my work commitments, my family commitments with my hobby and still get some sleep.
Yes. My name is Siavosh, and I work at the same IT security company as Michael. Like him, I have the hobby of analyzing malware, but I'm doing it more on statistical basics. And well, I'm not a father of 5. I'm still searching. So, you know. Anyway, yeah.
So why the strange hobby? Well, it started with I got myself a virus. I had all the protections you need. You had updated antivirus and everything. And suddenly I got the Microsoft firewall asked me, do I want this new process to listen to a port? It's like, no way. And how did this happen? I mean, I'm secure, right? I got the antivirus software. So I've started looking into the anti-malware industry. Before that, at that time, I was just a system administrator that I trusted my security features on the computer. I had a firewall, I had antivirus. I should be fine, right? You know that. I mean, can I have a show of hands? How many of you have done some malware reversing at all? So about a third, half of you, about. Yeah, so you know how to do it manually. You start a virtual machine, start all the logging, execute the binary, poke around a little bit, stop it, look at through the logs and see what's happening. How long time does it take? Yeah, forever. If you're quick, you can have a turnaround time about 5-10 minutes. Well, I'm getting a lot of viruses. I'm getting about 2 viruses every minute. I don't have time to do it manually. So the drawbacks is time consuming, and after a while it gets boring, really, really boring. It's just so many fake antivirus you can take before you really puke. You want to have the interesting stuff. You want to be the one who discovers Flame or Stuxnet, not the one that, yeah, it's just the other fake antivirus. I'm sure you have seen this one before. Choose any two. You have cheap, fast, and good. If you cheap and fast, won't be good. If you want good and fast, won't be cheap. If you want cheap and good, won't be fast. But I'm asking, why choose? Why not just choosing all of them? Because I claim I can do it cheaply, I can do it quickly, and I can get pretty good results doing it. And the secret is automated. I mean, you need to take yourself out of the process. You need to get yourself out of the way. Let the computer do the work. The computer has no family commitments, no work commitments, don't need bio breaks, don't need sleep. And they're cheap. So I started documenting this one, and it went from being my weird hobby. It always was communicating like that. Michael has a weird hobby. He likes to collect viruses. And yeah, I collect viruses, like stamp. And like Michael's weird hobby is not really a selling point. It's what you do. I have a weird hobby. So I said, okay, let's call it something. So I come up with the acronym MART, Malware Analysis Research Toolkit. And it's not a new tool. It's a bit of glue scripting around existing tools. But it's documentation, it's a process. And it's a documented, open. Anyone who read my blog can get it. So how is it built? Well, I'm using a lot of components. I'm running a Ubuntu system using VirtualBox, running a software called Cuckoo. Cuckoo is the main workhorse in this setup. It's the one who starts the analysis, loads the virtual machine with malware, records all the behavioral of the process, and put it down again, revert to snapshot, and go all about again. And also, I'm concentrating on Microsoft-based malware. So an MSDN license is a really cheap way to get licenses. If you're doing Microsoft, I mean, yeah, sure, you could go to Pirate Bay and download a bunch, but it's not that bad. And quite good. Still not really cheap, but cheap enough. Here's the architectural layout of the process. And you can see up here, you have me. I have a GUI console talking to a database. I have the Cuckoo system. I have input sources, and I have analysis sources. So let's talk about this one, sample acquisition. As I said, I'm getting about 2 samples a minute. I'm doing that from public sources, like I'm scraping CleanMX. There are a mail washer service in Germany. So I'm grabbing all the viruses they link to. I'm also doing exchange with other people like myself. And there are coming 2 sorts. They have the people who analyze malware, like myself, and they have the people who collect them, that trades them, that they work like a wares trader. Like I have the quickest, I have the newest, I trade you for something. So I have some of those connections. I'm getting a lot of samples to analyze. And yeah, then you have your private connections, which is private. I also developed a new tool for surfing the internet, trying to get infected. That one I'm calling a browser spider. Because the current tools I found is, well, they implement all the technologies and then looking for executable code. While I'm saying that, no, let's do the real browser. Let's run Firefox, Chrome, Internet Explorer, Opera, with Flash, with Java, with all the plugins, the real thing. And then just program it to, click everything. It goes, I see a link, I click it. And then you analyze if the machine has been changed apart from what you expect it to be, like temporary internet files is okay. Downloaded files, spawn processes, no. Then you come on to the sample analysis. We're doing the Cuckoo sandbox, and we're doing a virus total lookup at the sample, just to see if it's known. Because if it's known, I'm not interested. It's unknown and behaves sketchy, I'm interested. If it's unknown and behaves fine, I'm not interested. I'm just interested of the things that are weird but not detected. And Cuckoo has a process. You grab a task from a database. Like you feed Cuckoo with analyze all these samples. It grabs the workload, prepare the machine for analysis, launch the malware in the virtual machine. You have different packages, so it's not just executable. It could be Word files, PDF files, whatever. And if it doesn't support it, you can easily extend it to say, okay, this kind of file you open like that. So if you have so like say you want open office capabilities, you just create that open office files opens with this program. So I'm just going to show you a quick demo how to upload a sample for analysis. It's really short, it's very simple. I chose the file I want to analyze. This is one of the test applications that Siavosh created. I'll ask you to bump it up in the queue because I have like 116,000 viruses waiting for being analyzed, and I didn't want to wait a week or so to get there. And I submit it. About 2-3 minutes later, I have the report. So what do you expect of the reporting? Well, we're doing the virus total reporting. We're also doing the Cuckoo reporting. It's stored optionally in MongoDB. I would say it's actually required if you want to do data mining later, but you don't really need it. But I think you should. What you get is static details about file name, size, file type, a lot of checksums, signatures, PID, jar signatures, and antivirus results. You're also getting Cuckoo signatures, which you can extend yourself. You say, if this and that, then raise a flag. So this one is creating an empty file, which it does because it's using the alternative data stream. And when you're trying to access it, it's not there. You have the screenshots of the environment. So you can see quickly if you don't get so much from this sample because it's waiting you to click next. Then you can load it manually and click next and see what happens. You're also getting static details like about the executable itself, how it's built up, what's DLL is importing. You also see what files it drops, if any. You get the network analysis, where it's talking to, how it's talking to. DNS requests, IP addresses, and web traffic. And you got the raw PCAP file if you want to take a closer look. And behavioral analysis, you get what files are executed, what mutex, what register keys. Now, I see I have a bit of time here. I'm thinking about showing you a live sample. Here. Can you see that one? This was a sample analyzed just before this talk. It's fairly visible. It's 31 of 42 anti-malware engines, so this one is clearly malicious. Oh, the industry thinks it's clearly malicious. You have some signatures. You see it creates executable files. It installs itself as a startup item, and it's detected malicious. These signatures, if you want to give Cuckoo to your normal IT staff in your organization, or any staff for that matter, I would simplify have to upload the sample for analysis and just give them this and nothing else, because they can't really think about what's happening. You also get like version info. So this one was originally called rwin.exe. Was copyrighted 2008, according to what the author said. As you see, it's not packed, as we can see. And you see all the DLLs is trying to load and what functions. For each drop files, you'll get the normal size, type, and checksums. For the network analysis, you see what hosts were involved and what they try to access. So, okay, Oz.com, I have a toolbar in my virtual machine that probably wants to call home. But then you have the Korea, and I don't know, doesn't feel good. And here you see all the HTTP requests it's performing. You see all the summary, and then you have the flow of the process, what it does at what time.
How far does it go into running? Will it start getting the new exes?
What good?
Will it start sort of following those HTTP requests to get new executables? Or?
So the question was, do I follow child processes if it executes another process? And the answer is yes. It has a flaw at the moment, which it doesn't find it can't follow if you inject yourself in another process. So if you Metasploit, you have it in Metapredator, you move to another process, it loses track of you at this moment. But the nice thing with signatures is that I can detect that step that you are moving away. So I can't see what you're doing afterwards, but I can see that you are trying to hide your tracks. You see it's doing quite a lot.
You had a hand back there.
Okay. Another question?
It may have been the same question. It was just if the malware is a download and it retrieves various other exes and does those, does it then analyze those exes as well, or does it resubmit those?
So the question is, do Cuckoo analyze the executables that have been downloaded? And no, you have to queue them up yourself. Unless they're executed by the current process, then they will be part of this analysis. All right. So earlier I talked about getting it to MongoDB, that you should be doing that, and it's because you don't always know what you're looking for. So you have all these details, and there are a static HTML form, but you want to have it in a database as well. Because yesterday I got the question when I did my lightning talk about, do I have seen any malware trying to activate the webcam? And I say, no, actually I don't know, because I haven't been looking for it. So now I'm getting back, I'm going to see what calls that is required to open the webcam, and then I'm going back into my archive and see, have I seen that?
Yes. Do you hear me? All right, great. So when the virtual machine analysis fails, and what to do about it. basically, when we started this, the Cuckoo software wasn't that good. I wrote a very basic NTFS stream, a file that dropped, created an NTFS stream and dropped another file. And it didn't detect that. After that, I wrote a very basic keylogger, very basic Windows hook using, didn't detect that either. Then around a month back, they come with an upgrade, and they actually detected this. Still, Cuckoo is very easily bypassed even at this moment. So this is one of the stages when it fails, basically. It's not good enough. And since it's a software under development, the solution to this is probably to develop more features, create more. I come up with an idea about the future now when we got this question about actually running the other execution binaries that, for example, a rootkit might be downloading. So that's one of the instances when it fails, and that's how to solve it. Another thing is that if it has user detection, for example, the malware is only attacking, it only wants to attack people in the Middle East, then it's not going to run on my box, clearly. It's going to detect where it is, and it's going to shut down, go to sleep, or even remove itself. So what can you do about this? One thing that we are considering is scripting user behavior and customizing the sandbox for the malware to make it run. And the same solution is for sleeping malware, of course. Another problem is when there are features in the malware that detects if it's running in a virtual machine or is sandboxed. And the solution to this is something that we're developing right now. It's under development, so I can't tell you exactly how it's going to work, but somehow we're trying to hack the motherboard of, basically do it like this. Instead of running the malware in a virtual machine with a guest OS and a host OS, we have a guest computer and a host computer, and we're basically hacking the motherboard of the guest computer, and thereby we get it to run directly on the hardware. So hopefully we're hoping that we can bypass the virtual machine detections or the sandbox detections that way. Another problem is, for example, if you download a PhD file, and this PhD file might use some vulnerability in Acrobat Reader, then if you have another PhD reader on the sandboxing, on the guest machine, on the sandbox machine, then of course you won't notice that this malware, that this is actually a malicious file. It's a malicious PDF. So there is no real quick fix for this at the moment, but we have some ideas, and I'm going to go into how you can iterate the sandboxing process, so you don't have to have a situation where you can either sandbox it or not sandbox it. You can actually do this in several steps. Also, at the moment, Cuckoo doesn't, as far as we noticed, detect any multi-stage attacks. It has a hard time, for example, if you have a binary that actually is shellcode vulnerable itself, but it doesn't do anything malicious. The only good thing about it is that the CNC server knows where it is, and that this binary, when it runs, is remote exploitable. So you basically have a vulnerability, but Cuckoo won't detect it, and probably no other sandbox either at the moment, because they don't detect that kind of stuff. They don't detect bad written code, unsecure code. So, yeah, here the only thing you can do is more advanced malware analysis, and then sandboxing more specific. All right, so the iteration process, and this is what I was talking about before. At the first step, we just want to sort out which binaries are malicious and which are non-malicious. We have to be 100% secure about this. If we have, for example, 100,000 samples, Mike is getting 2 every minute, then we need to just, at the first run, detect those that we're not going to work anymore with. We just remove them from the pool. And now, at the second, before the second run, before the second sandboxing run, we can divide the malware in different categories. We have a malware that doesn't do anything. We have a malware that tries to detect its environment or detects its environment. We have a malware that is encrypted. Well, we don't know if they're malware right now. We have a file that has encrypted code segments. Also, we have files that failed execution. Now, usually, this is where the manual analysis comes in, and you give it to some reverse engineer who is very experienced with reversing software, and he sits with the file. This isn't efficient enough for us. We want to run our sandbox one more time, at least one more time. So what we do is we're dividing the samples that are left from the 100,000 pool in these categories, and we create 4 new customized sandboxes. One that's supposed to run every malware for, say, 12 hours and simulate real user behavior. Somehow scripting, browsing, opening Word documents, doing stuff like that. The malware needs to feel like home here. The one that detects its environment, we can, after a brief static analysis, maybe see that, all right, this one doesn't run because this one doesn't run because they're detecting that they're on a virtual machine. So we just do the hardware sandboxing on them. The ones with the encrypted segments, we send them directly to the experienced guys. And the failed execution ones, it might be a DLL, it might be some kind of library, or that program that's supposed to run the file isn't installed. So we customize this, and we only need to customize one box. We customize this sandbox for those files, all those files, and we give it another run. So right there and then, we can one more time make a difference between the files that accidentally or somehow didn't run or looked malicious, and the files that are actually still possessing a threat and need to be analyzed further. Yeah, I've already talked about this. All right.
Yeah. So, as I said, I'm doing this cheaply. So, how much money do you think I spent on this one? You see here, how many things I spent 1,000 euros? Raise hands. How many spent about 900 euros? 700. No? 600. How much do you think it will cost? What? 0. Well, no, actually, the hardware cost. My time I can get away with it, but the hardware cost. This is how much I spent. I spent 520 euros on a computer. I actually checked earlier today. It has dropped significantly. It's about 100 euros cheaper now for the same machine I bought earlier this year. The MSDN license. Is anyone here from Microsoft? No one wants to say they are. Well, the thing is, they have a very interesting exchange rate. It's $699 or about 8,000 Swedish crowns. And last time I checked, the US dollars was worth about 7 Swedish crowns, not 10. Anyway, first year, I'm spending about 1,300 euros. Next year, I'm just doing new MSDN license, so it's 590. Earlier this year, I quit smoking. That saves me about 2,000 euros every year. And that's how I get the money to do this. I mean, for 5, I don't have that much spare cash. So I have to find the money somewhere. Smoking is a bad habit anyway, so. It's amazing what you can do. Oh, I didn't go through the time. How do I get the time for this? I mean, father of 5, working 40 hours a week, 2 hours commute. The secret here is the 2 hours commute. I have a 1 hour commute to work and 1 hour commute back to work, back home. I can do a lot on that 1 hour because the computer has done a lot for me. I just need to review the sample reports that fancy me. If I was doing this manually, I maybe, if I'm lucky, getting 4 samples analyzed on my way to work. Now I can review hundreds of reports in a very short time. So next steps is, we talked about a bit, we're trying to get it to run on hardware, and we are not talking about expensive hardware, we are talking about really, really cheap second-hand hardware. As I said, I don't have that much money for this one. I also want to try to get it to run on Android platform. It's where all the good things happen nowadays, or bad. Trying to get it to work on OS 10 is the next thing as well. That one will cost me a bit because I would need a Mac Mini and probably just do the hardware virtualizing. OS X both have virtualization issues as well as licensing issues. Talk about Apple, but not letting them run anything on Apple hardware. And last but not least, iOS. That one is at the moment very low priority. Apple's doing good job to keep the bad stuff out for me to invest any serious effort at this moment. But hardware and Android and OS 10 is what I'm trying to get time and money for. So, do you have any questions? Now we have the official Q&A. Slot. Yep.
What steps have you taken to protect yourself?
So obviously you're using these VMs. How are you ensuring that the malware in some way doesn't try and escape the VM?
Not really that much. They're running on the VM. They are having a separate network out to the internet. So they're isolated that way. Sometimes I run it through Tor network just to hide myself. And sometimes I give them simulated internet with using INetSim. It's been documented on my website, and I just wrote a chapter in Hacking's ebook about malware analysis. No, I'm not at the moment doing much to protect the virtual environment. I could probably do nuke the host machine every so, doing PXE install, something like that.
So I've done some manual research, just very noddy stuff into malware in the past. Something I've used in the past is something called FakeNet to deliberately force false updates. So if a malware is looking for an executable, it'll send a dummy executable across, and then I can do memory analysis and see it go down a failure route. Is that something that Cuckoo or this kit could do now, or is that? INetSim can serve. You can give INetSim like if you ask for exe file, you give them that. Yeah.
But Cuckoo doesn't do anything like that. I'm actually letting Cuckoo access the internet, so it gets the real stuff. And if it's spreading viruses, I'm actively participating in this for 2 minutes.
Cool.
Hi, is there a technical or a T&C reason why you haven't looked at Amazon and the EC2 platform?
Sorry, I didn't get to you.
Is there a technical or a terms and conditions reason why you haven't used sort of cloud computing and like EC2?
Well, cloud computing is interesting, but they cost me every time I run them, and after a while it's cheaper to buy one, and you have also have more control. But nothing in this setup stops you from running it on Amazon EC2. Probably in the license agreement, but technically no. You should be able to run it on Amazon or another cloud service provider.
Hi, we've just come from a talk from Rich Smith from Kairos, where he was demonstrating how he was using Python to download zip executable and execute it in memory as opposed to on disk. Surely one of the next steps for this could be PCAP driver integration, so that you could then see what was coming down the wire. So if you're not going to do if you're not able to do the static analysis, then you can at least see what's coming down the wire, so that then you can integrate that.
Yeah, that's actually point. Actually, I thought about it. I've done it before, extracting traffic from PCAPs. You do have the PCAPs, so you can go back and pull them out. In a previous life, I was working in a NOC and was hunting down a porn surfer, and he was transferring files over IRC, and I just grabbed the files over the DCC connection. Other story, but yeah, definitely going to extend it.
Any other questions?
Then back.
Have you thought about a vasectomy?
Come again?
Hi. Have you thought about maybe, he was talking about the previous talk about, using everything in memory. Have you thought about integrating into your VMs, it would take a memory dump and push it out and then maybe automate volatility or anything like this way? Then if you do have a bad guy who's letting everything run resident in memory, at least then at that point, because the snapshot was shut down and revert, at least in this point, then you would have a memory analysis of, at least the mem dump, something you could go back and look at. Have you ever thought about pushing out a memory dump as well and then using volatility to just automate that too? Or
yeah, actually I've been thinking about memory dumps. I haven't got any plans, immediate future implemented. As I said, I have about 10, 15 hours a week doing it. And right now hardware sounds cooler, but definitely there are some open source projects that can leverage doing that. So it's a matter of knowing when to extract the memory. Any more questions? No? And thank you.